Well, hello, hello, hello. That's one for each of you guys. Happy Thursday. You are so close to the 4-day break. I know you guys are excited. But we do have a little bit of work left in front of us. And as you can tell from the presence of all these words and symbols and letters and numbers, we do have some work to do. So why don't you guys pause the video and write down what you can, and then I'll rejoin you. Okay, so we have notes 3.3 continued. If you couldn't read some of my writing, remainder theorem. If a function is divided by a linear factor x minus k, then the remainder is r. We've been calling it r. But it's also, what's important is to note that it's the functional value at k. So the remainder, when you do long division or synthetic division, I guess you could do synthetic division, since this fits the form of the shortcut. Yeah, the remainder that we get is going to be the functional value. So remember all those times that we got 0 as a remainder? Well, that's because that was our y coordinate when we plugged in that x. It's our functional value. All right, let's use the remainder theorem to evaluate the function at each given x value. All right, so if this is our function, really, if you're asked to use the remainder theorem to evaluate the function, it's not going to be as easy as just inserting 1 and -2 and a half everywhere you guys see the x and getting an answer. That would be too easy. They want us to see that when you do long division or synthetic division, that your remainder that you end up with is actually going to give you the value you'd get if you otherwise plug this number in. All right, so to show that work, we're going to do the setup of the synthetic division, the shortcut. Before I do that, I want to check to see what my answers should be. So what I'm going to do is kind of cheat a little. I'm going to plug 1 in mentally for x here and here. So that's going to be 2 minus 7 plus 3. Well, I'm going to add the 2 and 3 and get 5 and take 5 and subtract 7. My functional value should be -2. I'm just going to put a little -2 right here. And when I do synthetic division, my remainder at the end should be -2. So for each of these problems, A, B, and C, we have 3 shortcut methods. All right, so the first thing we have to extract from this problem is the input value of x. It's not written in factored form, so it goes in its own little box here. Notice we're missing a x squared term, so we're going to fill in a 0. So we've got the 2, the 0, -7, and 3. All right, let's drop down the 2 and proceed with the algorithm. When you sum, you get -2. That's your remainder. So what it's saying up here is that your remainder is actually your functional value. So we just proved it. You do the same thing for part B and C. I don't think we need to do that, but on your problem that's being assigned, this is like number 44. I actually think they give you 4 different parts, and so you're going to have to do 4 synthetic divisions for that one problem. It's not difficult, it just might be a little time consuming. All right, so we have another objective. I think we have a total of 4 of them. They're all together not too bad. Maybe I can fit them all in one video, and if not, we'll just have to do 2. All right, second objective. Yep, use synthetic division. Yay, easy, to show that x is a solution. Well, if x is a solution, my remainder should be 0. So what I'm going to do here is I'm going to say, okay, what that means is r must be 0. So if I don't get 0, I did something wrong. And then once I do synthetic division, then I can take the remaining quotient, or take the quotient and factor it, it sounds like. It sounds like I'm going to be able to factor several times. All right, so here's our first example. If 4 is a solution, that means when I plug in 4 for x, I should get 0. But it wants me to do it a specific way, not just plug in 4, so I have to do synthetic division. So here we go. 4, 1, 0, negative 13, negative 12. Woo, success. Not finished though. I just did the first part. Let me come over here. So now I know that third degree equation can factor into x minus 4. Okay, remember, if x equals 4 produces a remainder of 0, then that means that x minus 4, the factor it comes from, is a factor. All right, and then again, these are the coefficients of the quadratic factor. So it would be x squared plus 4x plus 3 equals 0. So this cubic can be factored here, but it says factored completely. So what I'm assuming is that this quadratic can factor into 2 binomials. And if y'all spend a little time with it, whatever, if you want to guess and check or box, should be x and x here. And the factors of 3 that add to 4 would be 3 and 1. So here we go. We did it. We factored it completely. Had they asked me to find the zeros, I would just say they would be 4, negative 3, and negative 1. But the language of the question is just factor it. Yep, so just so you guys know, this is like number 48 that's on your assignment. Number 48. Okay, so we have 2 more objectives. For this third objective, I think it's going to be best if you guys just read the directions of a problem that we're going to do that's similar to it. So let me see if I can scroll down here. All right, sorry that's taking a while. All right, so these next, I think I'm going to do 2 problems actually. We're going to talk through one and do one. These will be examples like number 58 on your assignment. So why don't you pause right here, right now, go find number 58, problem 58 on page 278, and read the lengthy directions. Because I don't want to write that all down, and I don't want you to write all that down. So turn me off right now, and go read the directions for problem 58 on page 278. So this is problem 53 on that same page. This is the function, this is the factor. All right, part A says verify the given factors of the function. F, verify the given factor of the function. All right, so if I'm going to verify that this is a factor, then if I do synthetic division using -2, I should get a remainder of 0. Remember, that's processed in your brain. That's what you're looking for. Part B, find the remaining factors. Well, if you use synthetic division and your remainder is 0, then you know the coefficients that are left are going to be quadratic, and then you can just factor that to accomplish B. Part C is just to write it like we've been doing in factored form. And then from there you can list all the zeros because you have the factors. Okay, not too bad. So for this one, we'd use -2 with all these coefficients. We'd get a remainder of 0, a quadratic factor that into 2 binomials, and find the zeros. So I don't know. I just talked through that, but I think I want to do a different one. So we're going to do 57. So that's a stray mark. And honestly, I don't know why I put that in parentheses. I think they just did in the book, but you didn't need to. All right, so we want to do synthetic division, but remember the requirements of synthetic division are this coefficient needs to be a 1. So I can't take the shortcut, and I definitely don't want to do long division. All right, so how we get around this is by thinking about the 0 of this factor. And y'all think about it. If I set this equal to 0, moved over the 1 divided by 2, my 0 would be -1/2. Maybe y'all need to work it out, just set it equal to 0, solve it, and you're going to get -1/2. So an alternate way to write this factor, to use it with a shortcut, because I'm not going to do long division. Okay, I can say that if -1/2 is 0, then x plus 1/2 is a factor. So if this is a 0 or a factor, then that implies that this could be 2. Don't get caught up in it. I don't even know if the one you have is like, yeah, it is like this. Again, you can't do shortcut with a leading coefficient of more than 1. Think about the 0 of this factor and then rewrite it. Basically, divide everything by 2 or whatever that coefficient is. Okay. Bad news is you're just working with a fraction over here, but hopefully it won't be too bad. All right, part A, verify, which means we need a remainder of 0. Okay. Uh, 38. Half of 38 is 19, but we got to make it negative. The sum is -28. Half of 28 is 14, but it's going to be positive. All right, so there you go, part A. Part B, find the remaining factors of f. All right, so I'm going to take 6x squared, these are the coefficients, plus 38x minus 28, and I'm going to factor that. I'm going to pull a 2 out front. Maybe that'll make it a little easier as far as having smaller numbers. Oh my goodness. Yeah, I'm going to work down. Well, we know that this has to be 3x and this has to be x. We don't have very many factors of 14, but if I tinkered around with it a little bit, I would say this is going to have to be 7 with a plus in front, because that will give me 21, and this is probably going to be a -2. So B, part B done. Find the remaining factors of f. I did C. Use your results to write the complete factorization. So C, the complete factorization. So f of x equals, I had a 2. I don't really want to discard it, so I'm going to put the 2 up front, and then I'll probably take the linear factor that I started with, x plus 1/2. And then I'll come back and pick up these other 2 binomials. And just peek in real quick. See if you distributed that 2 in, you're going to get 2x plus 1 anyway. It all works out at the end of the day. D. List all the zeros. Well, just set each factor equal to 0. Right here, you're going to add 2, divide by 3. So that 0 is 2/3. This 0 is -7. Done. Objective 3. All right, let's see if we can get this fourth and final objective on the same video. So we'll just have one video. All right, so this is going to be an example for problem number 60 on your assignment. Okay, and this question is all about use the rational zero test to list all possible rational zeros, then find them. So it's not too bad. Because you're still doing synthetic division in this test, okay? All right, we'll just get this down and we'll add some background to it in a minute. We're looking for possible rational zeros. Okay, if you have a function and they give you a function and it's going to have some zeros that are rational, meaning you guys, if the graph cuts through the x-axis in a rational number, not like square root of 3, which is irrational, or square root of 7, but something of the form p over q, a fraction, you can make it into a fraction. If you have a function and it cuts through the x-axis, it has to cut through at one of these possible rational zeros. One of the zeros has to come from this list that we're about to create. So we have a fraction. The list we're going to create comes from the factors of the constant term of the function divided by factors of the leading coefficient. All right, so the function they give you has to cut through the x-axis in one of these numbers that we're going to generate by this formula. Okay. All right, so I'm going to do number 59 on page 278. So the directions say list all possible rational zeros. Got it. This is easy, especially when the leading coefficient is 1. Okay, what are the factors of the constant term? Well, either 3 or negative 3 will go into 3. And what are the factors of 1? Simple. This list is so small. All right, if you wanted to simplify, it's just positive, negative 3. So if this cubic has an x-intercept, it's, oh gosh, not number, positive, negative. If this cubic cuts through the x-axis in a rational number, it has to be either at 3 or negative 3. I'm not saying it does. I mean, it might have like irrational solutions, but if it does have a rational solution, then it has to be one of these numbers. Okay, and then it says what? To find the rational zeros. Well, this is a pretty small list. Your problem number 60 isn't much bigger. There's just more factors than 16. All right, so what you're going to have to do is you're going to have to test all of these factors in synthetic division to see if you get a remainder of 0. Because if you do, then you know it's a 0. So I probably would start out with testing 3. So in your problem, if you have like 4 choices, you're going to have to do 4 tests until you find the ones that give you 0 in synthetic division. Okay, so I'm going to start with 3. Remember, I'm looking for a 0 remainder because then it is a 0. Nope. This is not going to give me a remainder of 0. So if you graph this on your calculator, it's not cutting through the x-axis at x equals 3. All right, we have another factor yet in my list. I only have one more. Thank goodness. Like I said, I think you have a few more than I do for your assigned problem. Let's see if we get a 0 from this. Well, we might not. That's okay. I know it cuts through the x-axis. It just might not be an irrational number. Yeah, an irrational number maybe instead. Oh, this is looking much better. All right. So what does this tell us? That negative 3 is a rational 0. So just to kind of point some things out to you, notation, the function evaluated at negative 3, the functional value is this number, remember, is 0. Just like over here, remember, the function evaluated at 3 would equal the remainder. That was 2 objectives ago. All right, right here we see a 0. I don't know that it asks you to factor it, but you can. So if negative 3 is a 0, then that means the factor is x plus 3. And go down here. These coefficients would be coefficients of the quadratic factor. So that would be x squared, no linear term, minus 1. If they asked you to factor it completely, which they don't, but we're going to, because this kind of sums up everything we've done. You're going to have x plus 3, and you guys know that factors into x plus 1, x minus 1. If they happen to ask you what the zeros were, because that kind of ties into last objective, the zeros of the function would be negative 3 and x equals positive negative 1. Oh, well, no, actually they did. Duh. It says then find the rational 0. So yeah, I had to do that. Okay, so I used the one that I found to factor and then completely factored and went, hey, you know what? These two also produce 2 other rational zeros. So yeah, had to do it anyway. Okay, that's section 3.3. And if you guys have any questions, you guys know on Tuesday when we get back, we'll definitely go over them. But I think you guys have good notes and you should be able to get pretty far within the problem anyway. Have a great break and I'll see you guys next Tuesday.